The final quiz for this course. Originally I said the due date is Monday, but then I realized Monday is a bank holiday. So I changed the due date for quiz 10 to Tuesday next week, 12 noon, right? So please submit quiz 10 by 12 o'clock on Tuesday, 7th of May, right? I mean, you don't need to wait that long. I mean, if you have already done it today, if you have it already with you today, you can give it to me after the class. Okay? All right? All right. Now, I want to go over, I know some of you maybe did not come to my class on Monday this week, so I just want to go over what I covered on Monday this week. On Monday I talked about the exam. It seems some of you are scared about the exam. I mean, please don't be scared. You know, I'm being straight with you, right? The style of the exam will be different from the previous years, right? I even sent you an email, at least 4 duplicate emails, each saying the same thing about what exactly you need to learn for the exam, right? The last duplicate I sent yesterday, so you must have got an email yesterday saying details of the final exam, right? Unless you delete all my emails. Yeah? Probably, I don't know. Yeah, anyway, check your inbox if you haven't got it, okay? It tells you basically what exactly you need to learn for the exam. And on top of that, I have said this, right? The exam will contain 2 sections, A and B. Section A will contain 4 questions. You will need to answer all of them. So A1 will be on descriptive statistics, A2 will be on bias, MSc, unbiasedness, etc. A3 will be on test of hypothesis, namely one sample test. A4 will be on one sample confidence intervals. And section B will contain 3 questions. First, B5 will be on bias, MSc, consistency, unbiasedness. B6 will be on one parameter MLE, and B7 will also be on one parameter MLE. All right, and section A, you will need to answer all questions in section A, and section B, you need to answer any 2 of the 3 questions in section B. So in total, you will have to answer 6 questions, right, out of 7, okay? Section A, each question in section A is worth 10 marks, and each question in section B is worth 20 marks. So the exam paper will be marked out of 80, right? And the remaining 20% is what you've done as coursework, okay? All right? You guys okay or no? So this is what I've been saying. So that's one thing I talked about on Monday this week. Then I did examples. This is an example 6 on on one sample test, right? And you can go over it if you don't like. This is example 6 continued. Then I did another example. This is example 7 on one sample test, hypothesis testing. Yeah. This is example 7 continued. And this is example 8 on one sample testing, hypothesis testing. And this is example 9. I gave this as an exercise for you to do, but if you cannot do it, I don't know, did you guys have time to do this or no? You never have time, right, for me? Okay, anyway, if I have time later, I will do it, right? If I have time later on, I will do this. Okay, now what I'm going to do today, guys, is I'm going to talk about two sample test of hypothesis, right? So I'm going to talk about two sample tests. And this, as far as the exam is concerned, is not examinable. So you don't need to bother about this, right? For this year, it's not examinable, right? Okay, so I'm going to talk about four different two sample tests. The first one is the first one is if you have two different samples and you want to see if the population means corresponding to the two samples are equal or not equal. Right? That's the first one. The second one is right? It's the same thing that, again, you have two different samples and you're trying to test whether the populations they correspond to have the same mean, but given that the variances of the populations are unknown but equal. All right? And number three, right here, this is the most general case where the variances of the two populations are not known and not equal. And number four is testing for equality of proportions. So these are the four tests I'm going to talk about today. And if I have time left over, I will do some examples on one sample test, right? Okay. Okay, starting with number one. So okay, so I'm going to suppose So we have two samples. The first sample is x1 to xm, coming from a normal population with mean mu x and variance sigma x squared. The second sample is y1 to yn, coming from another normal population with mean mu y and variance sigma y squared. And the two samples are independent of each other. And we are assuming, as I said, we are assuming that the variances are known. That is, sigma x squared is the variance of the first sample, variance of the population corresponding to the first sample. Sigma y squared is the variance of the population for the second sample. They are assumed to be known, right? And we're going to test the, as you saw the week before the Easter break, there are three different sets of hypotheses. This is the first hypothesis where you are testing for equality of the means versus they are not equal, right? And the second one is second one here you are testing for equality versus the hypothesis that mu x is greater than mu y. Yeah? And the third one is right, so these are the three sets of hypotheses. And now I'm going to write down the rejection rule for each set of hypotheses. For the first one, right, the first one, you will reject a null hypothesis if this is greater than this, where x bar is the sample mean of the first sample, and y bar is the sample mean of the second sample, right? Right? So these are the three corresponding rejection rules. You may ask me where these rules come from, but that's something beyond the scope of the current course. When you move on to year 2, there will be a course called statistical methods. It's taught in semester 2 of year 2. And in that course, you will learn about how to derive these rejection rules, right? So I'm not going to teach them now, okay? All right, guys? And some of you guys asked me whether I'll be teaching any courses in year 2. Unfortunately, no. I mean, I used to teach courses in year 2, but from this year on, I'm only teaching year 1 and year 3. So I will miss you guys next year. But when you come to year 3, I will teach you guys some course. Okay? All right, number 2. Right. Number 2 is when the variance, we are testing for equality of means, but the variances are unknown but assumed to be equal. All right, so the case is like this. So you have 2 independent random samples. Right? So you see we have 2 independent random samples. The first sample is from a normal population with mean mu x and variance sigma squared. The second sample is from a normal population with mean mu y and variance sigma squared. So the variances are equal, but assumed to be unknown. So the value of sigma squared is not known. Okay? So in this case, we will look at the 3 different hypotheses one more time. Okay? All right, these are the 3 sets of hypotheses. Now I'm going to write down the rejection rule for each. So for the first one, we will reject the null hypothesis if All right, so this is the rule for rejecting. I will explain in a minute what SP squared is. Just give me a sec. But this one here is the percentile of the t-distribution, and you should know how to read it from the tables. I mean, if you had been to my tutorials, I showed you how to read this off the table, right? If you hadn't been to my tutorials, I can explain to you how to read it if you come to my room, right? Okay. Yeah. And this one. Okay. So these are the three rejection rules for the three sets of hypotheses. And once again, I mean, if you haven't been to my tutorial sessions and you don't know how to read the t-table, please come and see me, right? I will explain to you how to read them, right? Okay. Okay, so number 2. That's number 2. We are done. Then number 3. Oh, sorry. I forgot to say something. Oh, get back to number 2. Number 2, I forgot to say what SP squared is. SP squared is the following. So let me put a line here, right? SP squared is defined as follows. Is 1 Okay, this is the definition of SP squared, and it's known as the pooled sample variance, right? Okay. All right, we are done now with number 2. Okay, now the next one is number 3. All right, so this is the most general case where we have 2 random samples as before, so it's like, sorry, it's like this, yeah? So let me write it down. So you have these are the two random samples. They are independent of each other. And we are further assuming that sigma x squared and sigma y squared are unknown. So the values of the variances are both unknown, right? So in this case, the testing for the equality has different rules. So once again, let me write down the three sets of hypotheses. This is the first one. This is the second one. And the third one is all right. So these are the three sets, and the corresponding rules are as follows. Right, this is the rule. I will explain what these numbers are. Sx squared is the sample variance for the first sample. Sy squared is the sample variance for the second. And I will explain in a second, in a minute, what it is. Okay, so these are the three rules. Now let me explain what these different things are. So as I said, Sx squared is a sample variance, and I'm sure if you are revising for the exam, you should know what the sample variance is. It's simply 1 over the sample size minus 1 times all right, this is the sample variance for the first sample. And the sample variance for the second sample is 1 over n minus 1. Yeah, and A is a number. It's defined as follows. is a big number. So okay. Okay, A is this number here, right? So this is the sample variance for the first sample, the sample variance for the second sample, and A is given by this nasty expression. Okay. I mean, as I said, to start with, none of this material will be examinable, so you don't need to know any of this, right? Okay. Okay. Right, that's number 3. Number 4 is about testing for proportions, or testing for equality of proportions. Okay. So this one is like this. So you have, one more time, you have 2 independent random samples. So suppose so you have a random sample from a Bernoulli distribution with proportion Px, P sub x, and another sample right? Okay. So in this case, I mean, testing for equality of proportion, I mean, it occurs in many real life situations. Like, for example, if you want to see whether the proportion of people who smoke is the same between the 2 sexes, for example, the proportion of men who smoke versus proportion of women who smoke, whether they are equal or not equal. So that's a kind of that's just one example where you want to compare 2 proportions. Yeah. Okay. I'm sure there are many other examples you can think of, right? So once again, there are 3 sets. There are 3 sets of hypotheses. This is the first one. The second one is Okay, so these are the three rules, sorry, the three sets of hypotheses, and the corresponding rejection rules as follows. Right, so the first one, rejection rule is right, this is the rejection rule, where x bar is the sample proportion. So in other words, it's just the sample mean of the x's. And y bar is similarly is the sample mean of the y's. Okay? Right? And for the second set is yes, and for the third one, okay, so these are the rejection rules for the three sets of hypotheses, right? Okay, guys, any questions? So I have talked about the four different tests, each involving two samples, right? The first one is testing for equality of means when the variances are known. The second one is when testing for equality of means when the variances are unknown but equal. The third one is testing for equality of means when the variances are unknown and not equal. And this fourth one is testing for equality of proportions. So these are the four two sample tests. But none of these will come in for your relief. For your relief, none of these will come in the exam. Okay? Now, you have 10 minutes left, so what I'm going to do in the 10 minutes, I'm going to go back to example 9, which I gave you on Monday of this week. And I asked you to do it. Did you guys manage or not? Example 9. You always tell me that you don't have time. All right, let me see if I can show you how to do this. All right, this is example. Now, you're testing this versus this, and you're told alpha is the type 1 error, beta is the type 2 error. The question is to show that n is equal to this. Right. Now, let me start with beta, which is the probability of type Now, What's the type 2 error? What's the definition? You accept the null hypothesis when mu is equal to mu1. Okay. Now, what's the rule for accepting H0 in this case? If you look back in the notes, guys, you should look back in the notes for the one sample test. You should know the rejection rule. Look, this is, come on guys, this is mu equal to mu0 versus mu less than mu0. Right? You should look back in the one sample tests. What is the rejection rule? You remember? The rejection rule was, okay, let me write it down. This is the acceptance rule, which is the opposite of rejection. So it's going to be root of n divided by sigma times x bar minus mu0 greater than or equal to minus z1 minus alpha. Do you remember this? This I got this from what I did the week before the Easter break. Don't talk. Yes. Are you okay? No, we are assuming we know the variance here. We are assuming we know the variance. So this is the rule. This is the rule for accepting the null hypothesis, right? Assuming that the variance is known. Okay. Don't tell me where you don't know where this comes from. You should know where this comes from, right? Okay. Now, now I'm doing this trick. You should know why I'm doing this trick. Right. Now what can you say about this, guys? Condition on mu equal to mu1, what distribution will this have? It will have the standard normal, right? So this is the standard normal greater than or equal to minus Okay, so this is 1 minus capital phi sorry, this is mu0. All right, 1 minus this is actually equal to phi at you see how I got this is a property I have used that if you don't know this property, write this, you may want to note this down. I mean, phi at z is equal to 1 minus phi at minus z. This is a well-known property of a normal CDF, right? That's what I have used. right? Okay, let me put this over here. Okay, next page. Oh, you're running on the next page. All right, so we have, so that implies that and this implies that n is equal to sigma squared and this is what we need to prove. That's it. It's not difficult, is it, guys? Yeah? Is that clear or not? You okay? By the way, this should say, this should have said 1 minus alpha. There's a mistake. This should be 1 minus alpha. So otherwise it's correct. So this is the correct expression. You guys okay or not? All right. Number 1 now. If you've done quiz 10, can you give it to me now, please? And number 2, if you got if any of you haven't got the ARC coursework, please see me now, right? You should, all of you should have received your ARC coursework on Monday of this week. If you haven't, please see me. All right, guys, so the next lecture for this course will be Thursday next week, which will be the last lecture. So I will have some present for you guys when you come here as a good gesture, right? I will bring you some presents for you. All right, so please do not miss the last lecture on Thursday next week. correct. Yeah, it's correct.
It's correct.
Yeah, it's correct.
Okay.
Yeah, good. Thank you. See. Hello. You okay? Yeah. You got a question?
Yes, yes, please.
Yeah.
In the notes, I know that we don't need to know this for the exam, but I was just curious about why this has n degrees of freedom and this.
Yeah, the reason is that because here you're estimating mu by x bar, so you need to subtract 1 degree. You need to take away 1 degree because you are estimating mu by x bar.
Okay.
That's why you have to take away 1. Because you are using the data to estimate mu by x bar.
Okay, I see.
Yeah. Whenever you estimate something, you lose 1 degree of freedom.
Okay.
Yeah, so n becomes n minus 1.
Thank you.
See you.
Thanks so much.
Hello, guys. You all right? The last line? This one.
When you change the question, do you have the question as well possible? It maybe uses this.
Yes, this one.
So the inverse phi gets you
That's the
ZB,
same as that. Yeah, same as
and
this
then
one.
isn't minus, because this is a minus sign, you think that should still be just Z alpha? Rather than, because minus Z, 1 minus alpha is the same as a positive Z alpha.
Oh.
So I think the original question was right. Because the
Yeah,
minus,
yeah. I need to check this. Yeah, Zeta. Let me think. Just a minute. Sorry. This guy here is. Yeah, I think you're right. It should be alpha. It should be alpha here. So this becomes that plus. Yeah, yeah, yeah. I think it should be alpha here. Yeah. Thank you for that. Yeah, yeah. Hello. Yeah, yeah. No, I'm moving out. Sorry.